Hello students, today we will see the Norton's equivalent circuit. After the completion of Thevenin's theorem, we will go for Norton's theorem. For this one, we will call this one as a current equivalent circuit. So in this particular Norton's theorem, just remember, assume this is a circuit. Here RL equal to 5 ohm, R1 equal to 3 ohm, R2 equal to the same. We will take it like here it is 10 ohm plus minus 10 volts, R2 equal to 15 ohm, RL equal to, we will take it 5 ohm, and I will take this one as a 20 ohm. Okay, so for this we have to convert into Norton's equivalent circuit. So in Thevenin's theorem we have the voltage equivalent circuit, and in Norton's theorem we have the current equivalent circuits. So here we have to convert this circuit into, here we have the current source. Just check the sign plus minus, so direction of current is upward side. We will call this one as Norton's current in parallel with Norton's resistance, and again in parallel with what we have the RL, that is 5 ohm, where we have to find out the value of current, that is IL. Here we have to find out the value of IN. Okay, so first step is to find out the value of I of n. Okay, so for this one what we'll do, if any voltage source is there in the circuit, short this. If current source is there, make it open. Okay, and remove the RL, that is this RL we have to remove it, and remove RL and find out current flowing through it, that is I of n. Okay, now this is the steps for finding out Rn. Next one is to find out the value of Rn, the same as RTh. Means what we will do, we have to short the voltage source, open the current sources, and sorry, short voltage source and open current source. Okay, and find Rn from load terminal. Okay, so for finding out IN, the steps previously I will mistakenly mention that short the voltage source and open the current sources. That should be for finding out Rn. For finding out In, first I have to find out the value of what In. Okay, so find out the value of In, that is a Norton's current. For this one I will write down as it is. We have to short the load terminal. We will call this one as I of n. Here we have the voltage source, here we have the currents. So 20 ohm, 10 ohm, 15 ohm, plus minus 10 volts. Okay, so find out the value of IN. So IN directly find out by using current divider rule. For that one I will mention one more video that I have to upload it here after this current divider rule. So current divider rule, just remember, we have to find out the value of IN equal to, here we have the total current I of t. I of t, here we have I of t into opposite resistance. So for opposite resistance of IN is how much? 20 divided by total, that is 20 plus 15. Okay, so firstly we have to find out the value of I of t. I equal to what? V by R. So we just take it 10 into R value. R value is just check it 10 divided by R is what? 10 plus these two are parallel. 20 into 50 divided by 20 plus 15. So you have to solve this. 10 divided by 10 plus, sorry, 10 plus 300 divided by 35. Just solve it. I of t. Okay. Then afterwards we have to put I of t here. We will get the value of I of n in terms of amperes. Now we will find out the value of, so whatever the value you will get it, you just put it here. Now we have to find out the value of R of n. For R of n, short the voltage sources and open the load terminals. So from this one I have to find out R of n. Here we have 10, 15, 20. So R of n equal to, just check it, 10 into 20, 10 plus 20. This, that should be 50 is in 15 is in series with the parallel configuration of 10 into 20, 10 plus 20. So R of n you will get it 200 divided by 30 plus 15. So 215, sorry, you just do the cross multiplication, you will get the results in terms of here. Just put the value of R of n. Okay. So whatever the value you will get it, you have to just put it. Now I want to find out the IL. So IL, again I have to use the current divider rule. For IL we have R of n, sorry, the IL opposite current is IN into, for current divider rule, I of L equal to total current into opposite R, resistance divided by total R. Okay. So here I of N, that you have to find out, into opposite resistance for RL is R of N divided by R of N plus I of L. So you have to find out the value of I of N, R of N. You will get the results here by using Norton's theorem. Now we will again go for the next steps. For this one I will take the simple example, 1 ohm, 1 ohm, 1 volts, 1 ohm, RL equal to 1 ohm. Okay, here we have 1 volts. So we have to convert this in current source equivalent circuits. So just take it plus minus. So here plus minus I of n, here 1 volts. Similarly R of n, R of L, 1 ohm. Now we have to find out the value of I of n. So finding out R of n, I of n, just remove it, short it, find out the I of n. Okay, here we have the total current. So use the current divider rule, CDR. Okay, so directly we will get the value of I of n. So I of n equal to total current into opposite resistance. Opposite is 1 ohm divided by 1 plus 1. Okay, so firstly we have to find out value of I of t. So I of t equal to V divided by this 1 plus these two, 1 into 1, 1 plus 1. These two are parallel. So V is 1, 1 plus 0.5. So 1 divided by 1.5. So just check it. How will be the value? 1 divided by 1.5. So nearer about 0. 0.66 something ampere will get it. Okay, 0.0666 like this one we will get it. amperes. So here we will write down. This is a rough one. You have to do the calculations. Now, sorry, this is I of t. I of t 0.66. So I of n equal to I of t into 1, 1 plus 1, 0.66 divided by 2 I of n. So 0.66 divided by 2. Now we will find out the value of what? R of n. So finding out R of n, just remove it. Same method, R of n equal to, we have to short this. Now do the resistance calculation. Here 1 plus these two are in what? Parallel. 1 into 1, 1 plus 1. So 1 plus 1 divided by 2, 2, sorry, 1 divided by 1 plus 0.5. That should be what? 1.5 ohm. RL is 1. So find out IL. So IL equal to total current, that is IN, into 1.5, 1.5 plus 1. So find out IN is 0.66 divided by 2. Sorry, 0.66 divided by 2, 1.5, 2.5. We will get the value. Okay. So this is the method. So today's lecture we have to find out the Norton's theorem, Norton's equivalent circuit, that is current equivalent circuit. In Norton's theorem we have to complete circuit into convert the complete circuit into IN and RN. Okay, thank you.